go. Okay. And I need my gloves. And this is page 15, 1-5. And we're looking at the density of carbon tetrachloride vapor at STP, and this is review. We actually did this kind of question last year. And this kind of question could cause problems because you might look at it and be like, I have, other than the fact that there's an answer given there, and let's just pretend that answer is not given, okay? Let's pretend it's gone. There's no numbers in that question, right? However, we do know that it is at STP. And we do know that it is carbon tetrachloride, and we do know that we want the density. So we do know that we want density, which is probably grams per liter. We also know that we are at STP, so we know that we have 22.4 liters per mole. And we can come up with a number for carbon tetrachloride. Do you know what number we can come up with? Molar mass. Okay, so sometimes if you have no number, but you have a compound, you can be like, oh, I probably need the molar mass. And the nice thing about molar mass is, if you remember, it is grams per mole, and we eventually want to get to grams per liter. Good morning. And so that's really just going to be a single conversion between moles and liters, and we'll have the grams on the top, okay? So carbon tetrachloride, we have 1 carbon, 4 chlorines, so that's 12, and 35.5 times 4, which is 35.5 times 4 is 142 grams per mole. Oh, but then we need plus 12. Oh, whoops. 35.5 times 4 plus 12 equals, my apologies, that should be 154.0 grams per mole. And we were asked to find the density. And density is, we're going to cancel the grams, or no, we're not going to cancel the grams, because density is grams per liter. So we want to keep grams. We want to cancel the moles. Could you flick that black switch while you're there? Yeah, perfect, thank you. I'm like, why is it so hot in here? They turned off the AC. Anyway. Okay, so we have grams. No, we don't want to cancel grams. I keep trying to cancel grams. Obviously, I've not had enough coffee this morning. We want grams per liter, so we want to cancel moles. And we want liters to go on the bottom. So, and because this is a gas at STP, there are 22.4 liters per mole. And so we have 154 divided by 22.4, which is 6.875, which if we round that to 3 sig figs becomes 6.88. Let's see if that was the answer, 6.87. Maybe I was using a periodic table with more digits. That is always possible. Okay. All right, example number 3. Now we're going to be doing this, but we're going to be doing it with torr and degrees Celsius. And so that means instead of being at STP, we are going to have to use the ideal gas law. Sasha, would you mind closing the door, please? Thanks. So So we want to find density. Again, I'm going to scratch that out so we don't see it. We want to find density, and we know that density is mass over volume, so grams over liters. Okay, so we have carbon tetrachloride, CCl4, and we just found its molar mass in the previous one, so it is 154.0 grams per mole, and we want the grams per liter. So we need to take our moles and convert them to liters. How many moles are in this molar mass? 1. So we're going to take 1 mole and we're going to convert it to liters. And if this was at STP, we would simply use 22.4, but we are not at STP. We have 1 mole, that's going to be N. We have 714 torr. What does torr measure? Torr measures pressure. And if you forget that, it's okay because it is on your green sheet, okay, on the formula sheet. And we have 125 degrees Celsius. And what should we do with our 125 degrees Celsius? We should convert it to Kelvin. So we're going to add 273.15. And that's going to be, let's see, 125 plus 273.15 equals 398.15 Kelvin. And that is the temperature. So now we have a pressure, we have a temperature, we have moles, and what are we trying to find? We're trying to find grams per liter. We are trying to find liters, okay? Because we know that there's 154 grams per mole. We want to know how many grams that is. That's 154 grams per how many liters, okay? So this is going to be 154 grams per we don't know how many liters. And we're going to find liters by using the ideal gas equation. Can you remember the ideal gas equation? P, what goes beside P? V equals nRT, the pervert equation, okay? So now we have a pressure of 714, oh no, I want to solve first for volume because we're looking for liters. So we have V is equal to nRT over P. Okay, so N we know is 1 mole. You looking for a quiz? Oh, calculator, yeah, no worries. 1 mole. We need R. Which value of R do we want to use? Take a look on your sheet there. I have to go grab a sheet for myself. It's yellow? Yeah. Light yellow or dark yellow? That's okay. Why don't you guys just tell me what the R value is that we're going to be using? Okay, so we have 6.236, 62.36, and what is the unit? Liters torr per mole Kelvin. Excellent. Mole, -1, Kelvin, -1. Okay, and our temperature, oh, I can just barely squish it in here, 398.15 Kelvin. and our pressure is 714 torr. So we have 1 times 62.36 times 398.15 equals, divided by, I don't know why I pressed equals, 714, 34.773. And that is our liters. So that's not our final answer because we don't want liters, we want grams per liter. And that is the volume of 1 mole. Of the volume of 1 mole of CCl4 at that temperature and pressure. Not at STP, but at a different temperature and pressure. Makes sense, we're at a higher temperature, so the gas is expanded. We've got a larger volume than 22.4, yes? Does that make sense to you? Larger volume because our temperature is higher? Excellent. And our pressure is, what's STP and torr? 760. It's lower pressure as well, so yeah, it should be bigger. Okay, and so our final thing that we have to do is we have to say density is equal to 154.0 grams over 34.773 liters, which gives us 154 divided by 34.773 equals, and we get 4.428 grams per liter. Let's see if I did that right. The answer says, what does the answer say? 4.42. Okay, so we're close. Okay, within spitting distance. So I'm going to say that's all right then. All right. Method B. What is method B? Yes, I did. Okay, there we go. All right. 13.2b, method B. This is example 3. Okay, there is a formula that you can use, but it's not on your sheet. Okay? It is that molar mass is equal to dRT over P. Now, you might be like, what use is this formula to me if it's not given on my data sheet? Do I have to memorize this sucker? If you want to use it, you need to memorize it, okay? You can always just go this route, though, and just be like, okay, I know that I'm going to have 1 mole of my substance. I need to change that 1 mole into however many liters, okay? So that is always a go-to. But there is a way of memorizing method B, and it is, I don't know why I put it so far along. It is on page 18. And here is how you can memorize it. Because we have a little picture that you are unlikely to forget. Mr. Miyagi, okay, puts dirt over his pee, okay? I know, it's very, very silly, but if you want to use this formula, if you're like, I know I can convert back and forth between density and molar mass of a gas, because Mr. Miyagi puts dirt over his pee, so molar mass is equal to dirt, dRT, over P. Okay, so we can use that method if we want to. So let's go back to page 16. And we want density in this case, so we have to solve this formula for density. So density is equal to molar mass times pressure over R times T.
Okay, just a second.
So our molar mass was 154 grams per mole. And you'll notice, in order to save room, I am putting mole to the -1 for per mole. The pressure was 714 torr. The R value we're going to use is the one that has torr in it, 62.36. Did I solve that correctly? Yes, I did. Okay. And then that would be liter torr per mole Kelvin, liter torr per mole, so mole to the -1, Kelvin, -1. And then the temperature was 398.15 Kelvin. You can see how that's like a little faster, maybe. It just saves you a little bit of work. So we have 154 times 714 divided by 62.36 divided by 398.15 equals, and we get 4.428, which is what we got before. And our unit, we can look and we can be like, my torrs cancel out. My mole to the -1 cancel out. My Kelvin to the -1 and my Kelvin cancel out. And I am left with only grams per liter, which is, yay, a unit of density. Okay, so that is a tidy little formula, a tidy cat formula. Okay, there is a method C that uses the combined gas law instead of the ideal gas law. It is included in the key. Would you like to see method C? Yes? Okay, excellent. Method C. The combined gas law. So when you do your combined gas law, basically you're going to take PV, and that's the start of the ideal gas equation, yes? And then we're going to put NT on the bottom, because that's on the other side of the equation. This is how you can remember it really quickly. And you could put an R here, PV over nRT, so that's P1 V1 equals N1 R T1 equals P2 V2 over N2 R T2. Now, normally we don't put the R in there because R is a constant and we don't need it when we're doing like proportionality between the two. Okay, so we can get rid of the R. And what we can do is we can say we know that at STP, now remind me, what is STP? STP is 0 degrees Celsius and, sorry, 1 atmosphere, which is also 760 torr, yes? At that temperature, 22.4 liters is equal to 1 mole. Now, what we can say to ourselves now is we can say, what is the volume of 1 mole at, now instead of 0 degrees Celsius, we're going to be at 398.15 Kelvin. Which means that our 0 degrees Celsius will have to be 273.15 Kelvin. And our pressure is not going to be 1 atmosphere. It is from the question 714 tour. Okay, so we have P1 and T1. Yes. We have temperature 2 and pressure 2. Yes. We have STP, which is going to be P1 and T1. We have P2 and T2. We're asking for both of them are going to be 1 mole, so we can actually get rid of the N term up here. So we just have PV over T. Yes, if things stay the same from one side to the other, you can just leave them out. And we know that the volume at STP, which is V1, is 22.4 liters. So into our formula, P1 V1 over T1 equals P2 V2 over T2. You can solve this for V2 first, or you can plug things in. Sometimes, because I normally am an advocate of solving first, but sometimes because it gets confusing what I'm plugging in where, because there's like, I like to keep my 1s and my 2s on one side until I'm, dealing with it. So I would probably just stick with it as it is. I would put in my pressure 1, which is 273.15 Kelvin, times V1, which is the 22.4 liters, and that is over T1, which is 273.15 Kelvin. Oh, what? Oh, because my brain is not working very well. That would be why. So that would be 760 torr, and that would be 273.15 on the bottom. Thank you very much. 273.15 Kelvin. All right, there we go. And that is equal to P2, 714 torr, times V2, which is what we don't know, over T2, which is 398.15 Kelvin. So now V2 is going to be equal to 760 times 22.4 divided by 273.15 times 398.15 divided by 714, which is equal to 760 times 22.4 divided by 273.15 times 398.15 divided by 714 equals, and I got 0 because I pressed a number in there. Anyway, let's try it again. 760 times 22.4 divided by 273.15 times 398.15 divided by 714 equals 34.75. Is that what we got before when we did it this way up here? 34.77, 34.75. I feel like I've just made a little error somewhere. I'm not quite sure where. We have 1 minute left, so I'm not going to look into it too deeply. Okay, but you would end up with liters, and then you could put your 154 grams over liters. Now, for anyone who came in late, the fastest way of doing this, if you recall, is to use method B, which is Mr. Miyagi putting dirt over his pea. Can I assign you one question for homework? How about you do number 1? Okay, there you go. And then next week we'll give you some time to do some work on these. Okay, so next week will be a work class so you can do more of these problems. This is the assignment is on page 19. Do number 1. What? That's early.